sleep. First thing we want to do is make sure you know what we're doing today. I can statements over here on her math wall, along with her vocabulary. And our I can statement today is that I can identify arithmetic patterns, including patterns in addition table or multiplication table, and explain them using properties of operations. Okay, so that's kind of what we're going to work on today. In your mind, what is a pattern? How do I identify a number pattern? So if you know that, how can I identify a number pattern? You got any ideas I need to know?
It's the way that it's put in, like maybe there's like numbers is 2, 4, 6, 8 and stuff.
Okay. All right, good idea. 2, 4, 6, 8. I see a pattern there. What is the pattern?
Look at numbers 0 through 20. Just numbers 0 through 20. Put your pencil on the number 0. Now, if the number 0 is considered an even number, I want you to circle it. And as you circle or not circle, I want you to go through the rest of the numbers through 20 and see if you can identify the even numbers. And if you can, circle them from 0 to 20. So here we go. Starting with the number 0. 0, 1, 2, 3, 4. We are only circling the even numbers. 5, 6, 7, 8, 9, 10, 11, 12.
Even numbers circled, I want you to look at those even numbers and tell me what you notice about them. Talk to your partner right quick. What do you notice about it?
Going down is like 2 plus 10. 0 and 8.
Okay, everybody give me your attention. What did you notice?
There is there one's place.
What's in the ones place?
Going down, there like 12, and 2 is in the ones place. 14, 4 is in the ones place. 16, 6 is in ones place. 18, 8 is in the ones place. And 20, 0 in this one's place.
Very good. He just identified numbers that you will always see in the ones place if it is an even number. Same odd numbers from the ones place, okay? So we're going to start with 11, and we're going to call out the ones who have an odd number in the ones place. Ready? 11,
13, 15, 17, 19.
Very good. So I think we've got the difference between an odd and an even number. But I want to ask you this. If I had a plate of cookies and I needed to divide them out, would I be and I wanted everyone to have the same, would I be using an odd number or an even number? Even number, and why would that be?
Because even is equal.
Even is equal. An even number is always divided equally. But what about an odd number? Yes, ma'am.
Odd.
And what does that mean?
Because odd, that means that you don't have the same number as that.
And there would always be what left over?
1.
1. But I guess we could give that to me, right? It means that we take a number and we add a certain number to it. And then we take the answer to that and we add the same number to it. And then we take the answer to that and we add the same number to it. And that creates a what?
Arithmetic pattern.
Say that again because I cannot say it correctly. Arithmetic pattern. Okay, and we're adding what?
A certain number.
A certain number each time. Okay, hold it up and I'm scanning. Here we go, quickly. All right. All right. Ooh, I think I'm too close to you. You got 10, 11, I think there's 12. How many are in this class?
13.
The number 50. So let's make sure we understand, what did we add to 20 to get 30?
10.
What did we add to 30 to get 40?
10.
And so what would we add to 40 to get the answer?
10.
And what would our answer be?
50.
Very good. What do we call the answer
Product.
when we are what?
Multiply.
Multiplying. Boy, I was trying to quit. What about if we were adding?
Sum.
The sum. Very good. All right, I tried to trick y'all. It's not going to work. Here we go. Next question. Quickly. 13, 17, 21. 13, 17, 21. There we go. If you hold those crooked, sometimes it'll get the wrong answer. All right, so we're saying based on our results that the majority of you feel like 25 is the next answer. So why is that the next number in the pattern? Who can tell me? Yeah, why would 25 be the next number in that pattern? Well, what is the number we're adding? Maybe I need to ask that in a different way. What number are we adding each time?
4.
4. If you agree with her, thumbs up. Okay, so when we took 13 and added 4, we got 17. 17 plus 4 is 21. So 21 plus 4 would be 25. Another level. Are you ready for this? Are you sure you're ready for this? Because I'm wondering why we even need to know about patterns. Here we go. Let's flip off a light so you can see a little bit better. Watch the magician before your eyes, and you better watch closely because he is difficult to understand. You ready? Watch closely.
There's magic in numbers. And you don't have to be a magician to find patterns. Think of a number, say 538. Add up the digits. 5 plus 3 is 8. Plus 8 makes 16. Add again till there's only 1 left. 1 plus 6 makes 7. Now, take that 7 away from the number you first thought of. 538, take away 7, makes 531. Add up the digits again. And what do you get? Let's try that again with a different...
Okay, we're going to stop it first. Now I want you to tell me something. What did he do to get to the number 9?
Odd and even numbers are vital for air safety. If you're a pilot, you never want to get too close to another aircraft.
Big 7221, northwest to east, pressurization.
So there are simple rules about height or altitude to keep planes apart. Planes fly one way at 13, 15, or 17,000 feet above the ground, and the other way at 14, 16, or 18,000 feet. So odd and even numbers lead to safer flying.
Hands on top of your head. If you knew that planes had to fly at a certain place if they were going from left to right or east to west. Put your hands on top of your head. If you knew the altitude, the distance in which they flew was determined by the direction that they flew. How many of y'all knew that? Put your hands on your head. I didn't know that. We call those numbers a certain thing. They're very important to this multiplication table, right? Okay, who can tell me the correct word, that math word that you call 0, 1, 2, 3, 4, 5, 6, 7 all the way down, across and down on a multiplication chart? I got more than one that knows. On the count of 3, we're going to say it out loud. 1, 2, 3.
Multiples.
Oh, I heard it. Factors. Everybody look at this word factor. Now, our factor is what we start with, right? And we have to have 1 or 2 factors to get an answer. We gotta have at least 2. 2 or more. Thank you for adding that. So that is why you're going to see on a multiplication table the numbers across the top are factors, and you have the same factors going down the first column of the multiplication chart. Now, look at all the numbers on the inside. If these are our factors, what do you think those numbers on the inside are?
The product.
The product. If you agree with her, wave your hand high in the sky. 2 times 3 is?
6.
6. And how did you get 6?
Because if like let's say 4 plus 2, you would get the 6, so we're going to add 2 to the 4 to get the number.
Very good. And I think you both had that. So, column 4 and let your partner check it quickly. 30 seconds. Do 7. Out your multiplication chart we just worked on and pull out our investigation sheet right beside it, and we're going to do this together based on what answers we found. So keep up. We're going to start with number 1. I'm going to read it out loud, and I want you to help me answer this in words, okay? So that if we have a person who can't just follow along with our answer, we can explain our answer to them. Everybody thumbs down, and let's go to number 2. Read this out loud with me if you don't mind, so I make sure I'm on the right one. Identify 2 odd factors and explain what you notice when you multiply them. And it gives us an example there of 2 odd factors. 9 times 9. Who can look at our chart and give me a couple of more odd factors that you could multiply?
5 times 5.
Okay, 5 times 5. Yes, ma'am.
9 times 5.
9 times 5, because do they have to be exactly the same? As long as they are odd, okay? So choose your own. Okay, I'm going to come help you. What do we know about 2 factors that are odd?
If you multiply 2 odd factors, then your product will be an odd number.
Very good.
Like 11.
Everybody right.
5.
Let me hear those, okay? So, can you identify patterns now with odd and even numbers?
Yes.
Can you identify patterns on the multiplication table?
Yes.
Then do you think that we met our objective today?
Yes.
All right, great job.